So if this part is not clear to you, remember I said that before. To find out what is the coefficient associated with the x is basically by dividing the coefficient with the x in the differential equation divided by kc squared. And what's kc squared? Kc squared is, so this will become MB over EIC times LC times Kc squared is nothing but P over EIC. And EIC will cancel out. That's why in the result, we only have PLC here. We've been doing this for many, many different times. And if that's not clear to you in the past. Okay. Now, what we need to do now is just to determine these coefficients, A and B. How do you do that? Boundary conditions. From the boundary conditions, we know that when x is 0, there's no deflection. That's because it's hinge support. So YC at x equals 0 is 0. And also because there's no sideway. So we also know that when YC is at support at the joint B, there's also no horizontal deflection. And that means YC at LC must also be 0. Now, by plugging YC is 0 into X, here you know that you will cancel out sine, because sine 0 is 0, but you can find out the value of B. So YC of 0 equals 0 will give you the opportunity to find out the value of B in here. And in this case, B times 1 is 0. B times 1 plus 0 plus 0 equals 0. That means B is 0. And similarly, by using the condition of x equals LC, we can find out the value of A. And here I will just give you the final answer. That is MB over P over sine KC times LC. So please be careful that this is, now we have another subscript, but please do not just take the only LC as the argument for the sine function. The entire argument should be the product of KC and LC.
Professor, is that LC inside of the sine function?
Yes, that's
Okay.
what I'm trying to explain.
Okay, thank you.
I have been skipping this, but they all should be within the parentheses. Because now we have a subscript, so they may look a little bit lengthy, but it's not just sine of KC, but it's a sine of KC times X and sine of KC times LC. So similarly, we will develop the same force equilibrium for the B member. Now, for B member this time, similarly, we will ignore the shear deflection. That means we're going to ignore the force produced by the shear to the member BC. In this case, for the B member, we argue that the primary action for the bending of the B member is the moment, not the axial force. So the argument that we use to ignore this moment member is because that is the shear force acting on the column. But in this case, we are looking at the B member. So for the B member, we're going to ignore the axial effects. That means we were going to ignore the axial force produced by this internal moment. And what is this term? This term is the axial force acting on the moment here is the shear force produced by this MB, which is MB over LC, right? Because we said that we're going to ignore this, the deflection produced by the shear force on the column, and it's the same shear force, which is also this one here. We will also ignore it in the analysis of the B member, which is member BC. So this term is MB over LC. This was, of course, the one we called the VA before. We're going to set this to be 0. That means we will not include that in the analysis. So this way we can simplify our moment equilibrium. And the moment equilibrium will lead us to this. From the force free body diagram of member BC, we can obtain this expression, which is IEI. Now this time is for the beam, so it's not for the column. So we should call it EI sub B times YB double prime, because now we are not considering deflection of the column, we are considering deflection of the beam, minus MB must be 0. This is from summation of moment equilibrium. And to go further, we will have to divide everything by EIB. So this will become EIB double prime. And there's no Y term in here. So this would simply just become MB over EIB in here. Like this. Now, this is also a differential equation, except that it doesn't have the linear term. So what's the solution to this? The solution to this is written as, first, you have to consider the first order and the zeroth order. The first order is associated with X, and this X is along the beam direction. So we call the first one as capital C times X plus capital D, that's the zeroth order, plus the constant term. And remember, the constant term will have to be divided by K squared. Now, here we have to define a different K. Before we call it KC, now we have to call it KB, because there are different kind of Ks here. One is for the columns, the other is for the beam. So here we're going to call it P over EIB to be KB squared. This is different from the one we defined before, which is here. The key is just the association of the subscripts. This one is C, and this one is B. Now, if you divide MB over EIB with KB squared, that leaves you only with this coefficient P. So this part, the constant term, will become just MB over P. Actually, let me rewrite it, because I should start with the first order term. The first order term is D plus capital C times X plus MB over P times 1/2 of the x squared. Now here,
should there be a KB squared there?
we already divide everything by KB squared. And here, be careful with the first order and the second order terms. And there are two unknowns in here. Ideally, actually, the textbook flip these two. What they call the first one D and the second one C. If we follow this order, we should call the first one C and the other one D. So I'm just using the same symbol. So when you compare with the result on the textbook, you can match these two together. Now, because there's no sideways, that means the way to find these two coefficients C and D is by the same way to find the coefficients in the column deflection for the member AB. So this is for step 5. By using the boundary conditions for the column for the beam member. And this time, for the beam member, when it's 0, it's still 0. When the beam member is at LB, it will still be 0. Now the first 0 will give you what? The first 0 will give you the D. I know that on the textbook, sometimes you are provided with two boundary conditions and only directly to the results. But it's important for you to recognize that which condition gives you what result. So the first condition will give you which result? What can we get by using YB of 0? Yes.
D equals 0?
Yes. So please, I know it may be obvious to some of you, but to others, please do not couple all these results together. You need to know which result gives you what. So for the first one, we get D equals 0, and the second one, we get coefficient C. And coefficient C, you will equal to negative MB over P. Of course, you can write it as EI, either way you like. And so this is going to be 2. Actually, this should be P times, actually, it should be KB squared. I missed this one here. It should be 2P KB squared times LB. Should be like this.
Should it be on the numerator though? Because if you look at the definition of KB squared is P over EIB. So EI is P over KB squared.
Yes, you're right. So KB squared should be in the numerator. So if you want to do this by including the KB, and the KB squared is here. Like this.